Okay, for 63, we have a compound interest problem. So the original amount is 500, and it pays 8% interest. So for A, again, we're going to write it in the form y equals AB to the x, right? So A is the original amount, 500. And then B is the multiplier, so that would be 1.08. And X would be number of years in this case, right? Okay, and then B says how much money would she have on her 16th birthday, so we would say y equals 500 times 1.08 to the 16th. And we use our calculator, and we would get y equals 1712.97, right? So that would be $1,712.97. Not bad for a $500 investment. Okay, and then C says, what's the domain and range of the equation that you wrote in part A? So for C, right, the domain means what values can you put in for X. And this is, X represents years, right? X represents yearly compounding. So it would be integers greater than well, we could put 1 in. We could actually put a 0 in to find out how much the original amount. So I would say that it's greater than or equal to 0. This is a tough one because in general, sequences would start at 1. But in this case, you could put a 0 in to find out how much money she would have had at the beginning at 0 time, right? Actually, I take that back for this part. The compounding doesn't really happen in that sense. So this is a gradual approach, right? So this one is tricky. It's debatable. I would say that it's probably X is greater than or equal to 0. We could argue that it should be integer values because they're compounding annually, which means they're only giving you your interest after a 12-month period. But this is tricky. I would probably leave it as it's a number greater than or equal to 0. The range for this is, what could come out of this? Well, we could get values greater than or equal to 500, right? Because you can't go less than 500 if you put 500 into the account, right? You're guaranteed that that's there, and then it's going to be greater than or equal to 500 for the range.